MCQ 18 is with regards to redox reaction. So the question here demanded for us to find out what color change is going to be attributed towards the reduction of the named reagent, original reagent. So I mean, if it's general reduction here, we have SHOE, right? Either justifiable using oxidation state that's using S. So a plus itself is an oxidation, a minus is the act of reduction. If not, we can take a look at the manipulation of hydrogen. If we were to lose hydrogen, is oxy. If we were to gain hydrogen, is reduction. Or oxygen, gaining oxygen is oxidation. Losing oxygen is reduction. And finally, we could be also using electrons. Losing electrons is oxidation. And reduction is going to be through the act of gaining electrons. I would generally recommend to go with oxidation state itself. It's a little bit easier and it's more numerical in terms of calculation. So for the case of A, we do see that there's indeed a color change. Black actually appears to be blue, but do take note that this is a copper 2 becoming a copper 2. There's actually no change in oxidation state, so I'll not be selecting A. For the case of B, we have colorless aqueous potassium iodide changes to become a brown solution. Now this seems to be okay here because potassium iodide, if I take a look at option B, Ki tests for oxidizing agent. So if Ki can test for oxidizing agent, we're going to do a little bit of flip. It tells me that Ki itself is a reducing agent. And if Ki itself is a reducing agent, that would have then mean that Ki undergoes oxidation. So if there is really any change that's happening to Ki, and this is really the case here because Ki, alright, based off the knowledge we know is that Ki, when it tests anything that's unknown, that is an oxidizing agent, it will actually forms I2. And I2 is the reason why a brown solution is being obtained. But if we work backwards from here, if there's a brown solution, that means that Ki did reacted, but Ki undergone oxidation instead of reduction. So B is going to be out because the status is oxy, it's not reduction. Let's take a look at option C. Now option C here, there's a color change for my iron 2 chloride all the way to become my iron 3 chloride. So oxidation state increases rather than decrease, so this is an oxidation event. So the last one here, potassium manganate, KMnO4, actually tests for reducing agent. So it's going to be the same backwards route I'm going to adopt for this, just like my potassium iodide. So for it to test for reducing agent, I'll say that KMnO4 itself is an oxidizing agent. But now for KMnO4 to act as an oxidizing agent, initially KMnO4 undergoes a reduction process. So the original color of potassium manganate is actually in purple, and if there is indeed any reducing agent, it will actually becomes a colorless solution. This is based off KMnO4 forming Mn2+, although the equation is not really something that you should be aware of. So if there's a color change, as you can see, it became colorless, so that must have been it testing for a reducing agent because it has undergone reduction. So D is the answer for question 18.